probably could, you know, and then you would get, like, the teacher would think it's somebody in the class. And, okay. Yeah. All right. Okay, everybody listen up. Here we go. So, first thing is that you have to have this formula right here memorized. This is not something that will be on your formula chart or on any quiz or on any test that I ever give you. So this right here is one of the ways to, or the way you can find any of these missing 4 variables. Okay? Now, I think what got most people on this problem here, this number 14 on those notes from yesterday, is that you see the mean, and you can plug in the mean into the formula right here. Okay? And then you see that this is the x value, and that you are trying to, you know, your standard deviation is your variable. But what people seem to miss is that when they are telling you a percent below, this percent below is going to tell you, going to identify the z-score. Okay? So in summary, let's kind of talk about your z-scores. So your z-score is a location. It is that distance from the mean. Okay, and so I want you to think of it like your line in the curve, in the picture. Okay, so if you're doing this, then your z-score is this location here. And it's this location relative to the mean. All right. So your z-score is a line based off of this distance, okay? Now, there are 2 ways to get z-scores. So the 2 things that you do with a z-score is this. You either use this formula that you have memorized, or if they tell you a percent, then you do inverse norm of the percent below that line. So those are 2 different ways that you can get a z-score. If they give you all 3 variables, then you can get the score with all 3 variables. If they tell you the percent below something, then you get it with the inverse norm. Okay. So back to this, what we would do is inverse norm of the 0.35, and we get this. This is your z-score that we then translate into the real data. So we're going to translate it into the 1250 and the 1200 information, and that's what I have here. So this is our z-score, this is our x value, this is the mean, and we will be solving for the standard deviation. So when you do that, the algebra gives you something like this. I want you to keep your z-scores at 3 to 4 decimals. If you end up with something a little different than this, then I look back at your work, and if your work has the correct process, you get full credit. It's just you had a little different rounding of a decimal, and that's fine. Now, I will tell you, on AP, this filling in is required. So this step right here that I just marked, you have to have written down. Okay? And then you don't have to show me how you solved it from there on out. But you have to do this step right here. And the reason is because this is your identification of all the values. This is telling the grader that negative 0.3853 is the z-score, and that 1200 is in the place of the x, and that mu is 1250, and that you are solving for that standard deviation. Okay? So this is required. So it's not extra information. I have to have that written down. All right. Now, let's take a look at letter B. Because letter B says 12% above. But when we get our z-score, it always has to be in reference to what? Yeah, what's below. So therefore, I have to, invert it and think, oh, well, that's 88% below. So I then find my z-score by inverse norm of 88% below. I get that value. So I have the z-score, and I'm now going to put it into the equation. This, again, is what you have to show work-wise. And then you can do the work in your calculator and pop out the answer. You don't have to show any other work besides this. Okay? Then you can pop out the answer. Alright, so I actually want to take a moment and I'm going to talk to you about your homework that you're going to do. Okay? So let's go ahead and pull that out. So go ahead and pull out that homework. All right, so a couple things that I need to tell you about this homework right here, okay? Let me see if I can get rid of this thing here. Okay. All right, so on your homework, there is some instructions missing, so I want to fill you in on that, okay? So, and this is what you're going to be working on today in class. So, on number 1, it first asked you, it really just asks you to find the z-score, which is simply your inverse norm of your lower area, okay? But then, if you notice in the instructions, it gives you some real-world data here with a mean of 30 and a standard deviation of 4. And so, but it's left off instruction-wise that I do want you to go ahead and translate this z-score into the value related to a mean of 30 and a standard deviation of 4. Okay? So go ahead and translate it into the x value. Alright, so that instruction's messed up on that. Additionally, on question C, notice that it says the z-scores for the middle 20%. You are going to be getting its z-scores. It wants the value for this location and the value for this location. You are getting 2 values. So you have 2 separate answers. I'm not asking for this distance here. I'm asking for 2 values. Okay, and now one other problem that students today have had has to do with number 7. So please turn over to number 7. Okay, well, I'm going to go ahead and read this to you so we can talk through it. Number 7. Most people think that the normal adult body temperature is 98.6 degrees. That figure is based on a 19th century study has been challenged in a 1992 article by the Journal of American Medical Association. That's JAMA, and that's a very common medical journal that if you're going into medical school and such, you would be referencing. So the researchers reported that the more accurate mean is actually 98.2 degrees Fahrenheit, and the standard deviation is 0.7 degrees. So we're going to assume the normal model is appropriate. Alright, this first question seemed to be a little ambiguous and people didn't quite know what it's asking, so let me translate. Okay, question A. In what interval would you expect most people's body temperatures to be? Yes. Okay, so technically, I understand that the definition of most is, more than 50%. Okay? But for the purposes of statistics, what we find out is that we kind of define most as those that are not outliers. Okay? So, and especially when we're talking about our normal model. Okay? So, in order for a temperature to not be an outlier, then you need it to be within 2 standard deviations. So the question, the answers that I want for this problem are the temperature at this location, that's 2 standard deviations up, and the temperature at this location, that is 2 standard deviations below that 98.2. Okay? I'm not even really asking for the distance between those two, because that would just be 4 times 0.7. I'm just asking for these two temperatures. Okay? Alright, so what I want you to do is work in class on those. I'm going to also call you up and give you your test score, but you are working together. You have to have an understanding of this before you leave. Okay, you have to. Now's your time to get that. Alright. I will tell you there is one other thing that I told my other classes, and that is this. If you have questions that ask you for, here's most of the way the questions are phrased. They may ask you, what is the probability of something? Or what is the percent of data? Or what's the fraction of the observations? Okay, or what's the proportion of the items? These things are all synonymous. These things mean the same thing. And what they are, to us, statistically, is the area under the curve. Okay? So let's think about that for a second. If I had a z-score located right here and I wanted to know the percent of data above it, then I am wanting this amount of area. Okay? This is all of these things right here. The probability of something, the percent of the data, the fraction of it, the proportion of those items. So my question to you is, on our chart we can get those answers, but how do we get this value, how do we get this amount with our calculator? How are we getting an area with our calculator? Good. That is when we are going norm CDF. Because you know what this C is standing for? It is standing for cumulative area. Okay? So when you want an area, you are using the norm CDF from the lowest z-score to the highest z-score. Okay? And so in this case, my lowest z-score is wherever this is located, and my highest z-score is way out there at infinity. And what do we simulate as positive infinity? Positive 99. Okay. So in summary, please remember that the z-score is this location of this line. It's this distance. You can find it by this formula or inverse norm of the area below. And probability, percent of data, fraction of something, proportion of something is the area which you use the norm CDF for. Okay, so now you're going to work. All right.